Alright, so picking back up from the Unit 7 review for your AP Stat test tomorrow. For number, well actually this was number 6 on your review packet. So the larger the sample, the larger the spread and the sampling distribution. That is actually false. Okay, so remember that your sampling distribution is a collection of everybody's means. So if I'm looking at a line plot and I have maybe 3 people's means, that might be what their means look like. So I might have a data value here, here, and here. Now if I add in other people's responses, then I might get something that looks a little bit more like this, which is actually more of your normal curve. So basically what this is saying is that the larger the sample, the larger the spread. It actually should be the smaller the spread in a sampling distribution. Okay, so this is a false statement. For number 2, statistics from smaller samples have more variability. That is a true statement. And again, from the same thing, statistics from smaller, it should be statistics, so from larger samples have less variability. So statistics from smaller samples have more variability. And again, that just has to do with the number of items that you have in your sample. Okay. The next one was actually number 8 on your review packet, but number 3 here. Suppose that 35% of all business executives are willing to switch companies if offered a higher salary. If the headhunter randomly contacts a simple random sample of 100 executives, what is the probability that over 40% will be willing to switch companies if offered a higher salary? So again, probability that over, this is going to be a p hat because you're given a parameter here, is over 40%. So there's your probability statement. In order to solve for this, you're actually going to end up eventually doing a normal CDF of a value, whatever your z-score is, up to 99. So we have to first find what that z-score is. In order to find the z-score, I have to convert this. So z equals the value I'm converting, which is 0.4, minus the mean, which is your parameter, 0.35, divided by, again, this is your standard deviation of the proportion problems. So you have to do p times 1 minus p divided by the number in the sample, and the number in the sample is 100. Okay, so when you convert all of that, you're going to get about a z-score of 1.04. So that's what you're going to put in right here, 1.04. So you're going to do a normal CDF of 1.04 to 99, and you're going to end up getting about 0.1469. Okay? Now you might not get that exact 0.1469, I get 0.1491 when I put that exact thing in, but again, it's going to depend on how many decimal places you round to and when you round in the problem as to how close your decimal is going to be. And that's going to be really flexible. Okay, number 4 on here, but it's actually number 9 on your review packet. Number 9, the correct answer was A, and this is the way you get it. Again, it gives you the average and the standard deviation for a population, so you know that this is a central limit theorem problem. And you're looking for the probability that the mean is going to be over $200. Okay? So, for that, you're going to have to convert that 200 to a z-score. So 200 minus the mean, my mean is 187.50, divided by the standard deviation of the population, 54, Now, you are going to have to convert this, 550, divided by the square root of your number in your sample, and in this case it's 50. Okay, so you're going to plug all that in to get a z-score, and then you're going to do a normal CDF. I don't know why my pen's doing that, I apologize. Normal CDF. Just doing that little thing here at the end. And then it's going to be greater than 200, so you're going to take from your z-score, whatever you get when you put your z-score in here, and you get about 1.62. Okay, so that's going to be 1.62 to 99. Normal CDF, and again you get about 0.0526. Okay, and then number 10, actually, this should be number 10 on your packet. Again, this was number 9, this is number 8, this is number 7, and number 6. Alright. Number 10 on your packet, the average number of daily emergency is 85 with standard deviation of 37. This is a central limit theorem problem because you're given, not GTL. My pen is not cooperating with me right now. So central limit theorem, again, central limit theorem. There we go. Alright, so you're looking for, in a simple round, what is the top 5%? So top 5%, you're going to work backwards here. So in this case, normal curve, mean is here, top 5% is up here. Okay, so that's the 95th percentile. So you're going to first do an inverse norm on 0.95 in order to get your z-score. Okay, so when you do that, you get 1.6, about 1.645, we're going to say. Okay, so that's going to be what you set it equal to. That's your z-score, is equal to, you're looking for the value that separates it, minus the mean. The mean in here is your 85, divided by the standard deviation of the sample. So you take the standard deviation of the population and divide by the square root of the sample, which is 30. Okay, and then you are going to solve this equation for x. Okay, when you do that, you're going to get C. It's going to be something close to that, depending on how you round. Alright. As far as the free response questions go, in your packet, your next free response question, this is actually number 11, I'm sorry about the misnumbering here. For all of these are going to be a little bit more critical when we get into the review on Wednesday. These are a binomial problem for letter B. I would expect you to know how to solve C if you were given all of this information. So for letter C, it says the mean and standard deviation of x are 1.65 and 1.85 respectively. Suppose 150 household areas are to be selected at random, and x bar, the mean number of dogs, cats per household, is to be computed. Describe the sampling and distribution of x bar, including shape, center, and spread. So again, you would have to know that since this is a bigger mean and you're looking at mean sampling distribution, x bar, that this is a central limit theorem problem, and since it's central limit theorem, you know this is your n, and then this is your mu, and this is your sigma, and then plugging all that in, you would know the center was the same as the mean, so 1.65, again bell-shaped because central limit theorem, meaning approximately normal. Okay, and again calculating the standard deviation for this, that would be kind of describing the sampling distribution, shape, center, and spread. Okay, so that would be helpful. Same thing as with the next free response question, number 12. Again, A and B, not so much. You should be able to calculate A, which is the 70th percentile of the distribution of stopping distances. Wouldn't necessarily expect you to know B for your test tomorrow, but it would be very important for your exam. And then the last problem, you should know how to calculate one like this, because again it gives you your n value, and it also, you're looking for the probability. What's the probability of what you just calculated here? So you have to use this probability from the previous problem, but that's something that you would know on your test. So let's see here. So you're looking for the probability of at least 130 feet for n equals 5. Convert that to a z-score. There's your standard deviation conversion for the sample, and that's what you're actually going to put in to find your normal CDF. So I guess you actually don't need this 30% for part C. But I would expect you to know how to do A, and I would expect you to know how to do C on your test tomorrow, not necessarily the binomial problem for B. Okay? If there are any questions, please let me know. Quick reminder that your test tomorrow will really just be identifying whether or not it is a proportion problem or is a central limit theorem problem. Okay? Proportion, remember you're going to use the mu sub p hat and the standard deviation of p hat. This is just equal to your p-value. P is your parameter of the population. Okay? This is going to be equal to the square root of p times 1 minus p divided by n. And then for central limit theorem problems, you're given the mean, mu, and you're also given sigma of the population. So therefore, the mean of the sample is going to be equal to the mean of the population, and the standard deviation of the sample is equal to the standard deviation of the population divided by the square root of the number in your sample. Okay? Remember your two criteria: simple random sample for proportion, and n times p should be greater than or equal to 10, and n times 1 minus p should be greater than or equal to 10. Okay? And then over here, again, simple random sample, and number 2 is n is greater than or equal to 40, or you know it's from a normal distribution. Okay? So those were the two main concepts of this unit. You do need to make sure that you know the normal curve. You need to know how to use normal CDF. And you also need to know how to use the inverse norm when you're given a percentile. Alright, if there's any questions, please make sure that you see Mrs. Conway tomorrow morning.